chapter number 13. And if you remember last time, can you see my screen, Azam?
Yes, sir.
Okay, perfect. So if you remember, we covered payback period, internal rate of return, net present value, and then we also covered profitability index. So net present value, this is something really, really important. So what net present value does actually, it gives you a net present value of all cash inflows. So let's say cash flow number 1, and you divide it by, let's say, k raised to power 1 plus cash flow number 2, 1 plus k raised to power 2. And let's say we have n cash flows. Okay. And then, of course, you have to subtract the initial cash outflow. So NPV, for example, here in this example, an NPV of minus 1,424. Where does this money go? And who is benefiting from it? Or let's say who is taking these losses? Azam, what do you think?
So according to the NPV criteria, so because it's not equal to or greater than 0, so we will not accept the project. So
yes,
there's a loss incurring.
There is a loss here, right? But let's say if there is a project where the NPV, let's say, is $5K. So where does this money go? Let's say if they accepted the project, the net present value of the project was $5,000. So where does this money go?
To the shareholders.
To the shareholders. Perfect. Right? So let's say if the NPV is high, shareholders benefit from it. But let's say if the NPV is negative, as I said, I think in my previous lecture, sometimes NPV and all these approaches, it does not take into account the managerial options. So for example, let's say there is a project and the management thinks that if we take this project, although the NPV is negative, but in future, actually, it will give us certain options. For example, let's say to geographically expand to those areas. So sometimes they may consider a project with the negative NPV. So if there is a negative NPV, of course, the shareholders lose money in shorter term. But let's say if it's a positive NPV, of course, that money goes to the shareholders. So it increases the shareholders' wealth. Project relationship, the first part I already covered. So one of the assumptions is that the project has to be independent. And from independent means that its acceptance or rejection does not affect the acceptance or rejection of other projects. There is another terminology, it's called dependent, which means that a project whose acceptance depends on the acceptance of another project. Example, there's an example in the book. For example, if a company is considering to, let's say, acquire, let's say, a certain machinery. Okay. Of course, if they would like to acquire that machinery, sometimes what they need installation facility, like a building or anything, right? So acquisition of machinery, it's one project, and then its installation facility is another project. So one project actually depends on the other project. So the company will only make the installation facility, like building or anything, if they acquire the machinery. So the acceptance of installation project depends on the acceptance of acquisition of machinery. So certain projects are dependent. They go hand in hand together. There are certain projects which are mutually exclusive. And for mutually exclusive, as the name suggests, you pick only one. So for example, let's say if you're considering to pick between two projects, you take only one project. and the other one you do not undertake that project. And example is, again, let's say if you're considering to, let's say, introduce some IT-based solution, for example, let's say Oracle ERP, let's say, to your organization, right? And there are some other, let's say, competitors. I'm not aware of any other competitors, but let's say you're going for a very, very, let's say, simple solution, which is QuickBooks. It will still do your a job, let's say, for maintaining your accounts. But Oracle ERP, of course, it's an enterprise-wide solution for that. So let's say if you accept one, you do not accept the other one. So you are going only for one. So there are multiple options, let's say 5 or 6 options. If you pick one, you do not consider the other one. So those projects are called mutually exclusive. Now, there are certain problems especially in mutual exclusivity. One is called scale of investment. The other one is called cash flow pattern. And the third one is called project life. And we will cover actually all these one by one. And these are very, very important. So we learned about the tools. So 4 different methods. Now we will use them to different scales of investment, different cash flow patterns, and different project life cycles. And then we will see their limitations and some of the strengths as well. So for example, scale differences. So there are 2 projects here. As you can see, one is small and the other one is large project. And the smaller one, as you can see, it needs an initial investment of $100. And the larger project needs $100,000 investment. In the first year, there is no cash flow. In the second year, there is a positive cash flow. So let's say cash inflow of $400 for project S, which is the smaller project, and $156,000 for project L. Now, the difference between the size of the project is like one is only $100, the other one is $100,000. Now let's see what happens. So if I calculate the payback period, the IRR, and NPV, of course, for NPV, you have to pick K. IRR, we have to calculate K, which is like the required rate of return. Here, NPV, the required rate of return is given. For PI, the required rate of return is also given. So let's say if I ask you a question that which project is preferred and why. So if I calculate the IRR, okay, I actually did not calculate the payback period because that's too simple. IRR. So IRR is 100% for project S. NPV is 231. And profitability index is 3.31. For the larger project, IRR is 25%, NPV is 29,000, and the profitability index is 1.29. And if I may ask you, how do you calculate it? It's again pretty simple. IRR, you can simply calculate it in Excel. What you do, you actually input all your cash flows, and then you calculate it. NPV, again, very simple. You use 10% K. So for example, for this project, let's say for S, NPV for S is equal to, so $400. So we do not use this one because this one is already 0 divided by 1 plus 0.1 raised to power, because I'm discounting this 400 for 2 years, so that's why it's square. And then minus the initial cash outflow is $100. And if I use my calculator, let me do that for you. Azam, do you have a calculator?
So not at the moment.
Okay, let me calculate it for you. So that's not a problem. Okay, so this is 331. Okay, so if you see here, the profitability index is 3.31. So how do we calculate profitability index? Is 331 divided by 100, which is this one. Oh, sorry, minus 100. So NPV is 231. So NPV is 231 and profitability index, we take this number and instead of minus sign, we divide it here. So NPV is 231 and profitability index is 3.31. And similarly, you can calculate it for the larger project as well. The profitability index is 1.29. So based on IRR, if you see, smaller project is more lucrative because that one gives you 100% internal rate of return. But in terms of NPV, this one, because of its scale only, this one adds $29,000 to the shareholders' wealth. So of course, based on the NPV, the larger project is more lucrative. Profitability index, again, 3.31 is larger than 1.29, so the smaller project looks more attractive because of the higher profitability index. So this simple example actually shows you limitations of some of the techniques. On one technique, we accept one project, and then on the other technique, we accept another project. Another problem with these capital budgeting techniques is actually the cash flow pattern also affects which technique are we using for project ranking. So for example, there is a project D, which means that the cash flows are gradually decreasing, and then we have another project I in which the cash flows are increasing. So if you see here, for an initial investment of $1,200 in project D, the first year cash inflow was $1,000 and it's gradually decreasing. So that's why I labeled it as D. And then here in project I, the initial investment again is $1,200, similar to project D, but the cash inflows are increasing with passage of time. Now, in time value of money problems, any cash flow which is occurring at year number 1 is more certain than a cash flow which is occurring, let's say, at year number 3. So cash flow at year number 1 is more certain. So that one is less risky compared to third year's cash flow. And I'll show you actually in a graph as well. Project D graph is more steep, actually. The slope is more. I'll show you in the graph. So if I ask you, you can easily calculate the IRR, NPV, and profitability index. And in fact, I will encourage you to calculate all these numbers. Once you calculate those numbers, of course, you can easily, practice how to calculate IRR, NPV, and profitability index. Now, based on IRR, NPV, and profitability index, which one do we prefer? If you see, the NPV and profitability index for both these projects are exactly the same. But if I consider the IRR as a decision criteria, of course, project D ranks high. And project D ranks high, the reason is the cash flows are more certain because the larger cash flows are occurring a little bit quicker compared to project I. So the larger portion of cash inflow is occurring quicker, and in project I, it's actually occurring at year number 3. So that's why the IRR is 23% for D and 17% for I. So NPV and PI, as I said, they yield into same results, but the IRR itself, if we use that as a decision criteria, project D, which comes with decreasing cash flows, it's more lucrative. So as you can see from this very simple example, that the cash flow pattern also affects the feasibility of a project. And of course, it also depends on which method are you using for project ranking. So to graph actually those numbers. Do you have any question? Okay, can you please mute your mic? Thank you. So D is actually this purple line. So the purple line, if you see, it's actually more flat. So I apologize, I did not make a correct statement, because the cash flows are occurring a little bit quicker, so that's why it's less risky. So the slope is not that steep. For I, it's more steeper, as you can see. So the net present value at 10%, this point, both of the projects are actually equally attractive. But if the discount rate, which is the required rate of return, is more than 10%, you can see that this D is more lucrative, because the required rate of return is more than 10%. So let me label it for you. So D is this one, and the purple one, yeah, the purple is D, and then the blue one is I. So if you see here in this area, the required rate of return is more than 10%. So D actually is more lucrative. But if the required rate of return is less than 10%, I is more lucrative. And the slope, as I said, is different because the cash flow pattern is different. This point where both the projects are equally attractive, that point is called Fisher rate of intersection. So the point at which both or any alternative projects are equally attractive based on NPV, that rate of return is called, that rate of intersection is called Fisher rate of intersection. Okay, project life differences. So this is the third difficulty that we face in project evaluations. So for example, the project life differences. One project, in both projects, for example, let's say we have a project X and we have a project Y. So project X, if you see, my initial investment is $1,000. In first year and second year, I do not get anything. The first cash inflow is in year number 3, which is $3,375. On the other hand, project Y, the initial investment is exactly the same. But in year number 1, I get a cash inflow. And then in year number 2 and year number 3, I do not get anything. So the project life cycle, or let's say both the project has a different life. One has 3 years of life and the other one has only 1 year of life. Now, if I calculate IRR, NPV, and profitability index, and I'm using the same 10% rate, which is the required rate of return. For project X, the IRR is 50%, NPV is 1,536, and the profitability index is 2.54. On the other hand, project Y has 100% internal rate of return, 818 NPV, and then profitability index of 1.82. So again, there's a question mark. Which method do we use? Which one do we pick? Because based on IRR, of course, Y is more attractive. But based on NPV, project X is more attractive. And profitability index results into the same, same decision. Project X is more attractive. So the point is that the project life also affects which method do we use for project ranking. Okay, so there's another way we can look at the previous problem. So if you see here, this $2,000, what we can do, we can extend it. For example, if I get $2,000 here at year number 1, then I can actually invest that money at 10%, and then I can find out what do we have here at year number 3. So if you see here, $2,000 at the rate of 10%, if I compound it for 2 years, so this $2,000 was occurring here. What I did actually, I compounded it. I calculated the future value at 10%. So if I do that, of course, it will affect the IRR. Now the IRR is 34.26%, and the NPV stays the same. Or what we can do actually, we can use a chain approach. So let's say, but there is a big assumption actually here, that let's say project number 2 is something that can be repeated. So I invested $1,000 now, and I'm getting $2,000 in year number 1. I again invest $1,000 in the same project, and I get $2,000 in year number 2. And I do exactly the same thing in year number 2. So if you see here, the net cash flows, year number 0 is $1,000, year number 1 is $1,000 again, year number 2 is $1,000, and year number 3 is $2,000. And if I calculate the IRR is 100%, but the NPV jumps by a lot. It's 2,238. And if you see, initially it was only 818. But as I said, the biggest assumption here is that project Y is something that I can repeat all the time. Like that is the kind of opportunity that I have all the time, and I can take advantage of that. So that's a big assumption. Capital rationing. Now this is something super important. Now, of course, as a company, you do not have unlimited budget. You have to work you have to invest within your means. So there is also what they call a budget constraint or a budget ceiling. So let's say if I place a budget ceiling on total, let's say, capital expenditures, how does different projects look like? So I'll give you a very good example, and then you can see that a budget constraint actually affects which method gives the highest NPV, because at the end of the day, NPV is something which matters, because this one adds value to shareholders' wealth. Or let's say, well, what should I say? It increases shareholders' wealth. Of course, positive NPVs, not the negative NPVs. So let's say Julie Miller must determine which investment opportunities to undertake for basket funders. She is limited to a maximum expenditure of $32,500. So again, what Julie is doing, she's considering to pick certain projects, but the limitation is the total money she can spend is $32,500. So if you see here, project number A, the initial cash outflow is 500, So it means that the investment needed is $500. IRR for that project is 18%, NPV is $50, and then the profitability index is 1.1. So suppose Basket Funder has these 8 projects to choose from, and the total budget allocation is $32,500. So there is a budget constraint. Now, the other constraint is, of course, you cannot pick a project in parts. It has to be a full project. So for example, you cannot do that, okay, based on the NPV profitability index, since the profitability index of, let me see, okay, 2.4. Okay, I apologize. So 2.4 is the highest profitability index for project F. So let's say you cannot do that. Okay, I will invest $15,000 in project F, and let's say only $2,000 in project B. You have to either take it all or leave it all. So that's the project. I mean, so you have to take it all or leave it all. Okay, so if I choose projects, based on IRR, I will only choose C, F, and E. Okay, and the way you do it, you rank all the projects based on IRR. So from high. Okay. Can we please mute the mic? Okay, so if you are choosing projects based on IRR, what you are doing, first of all, you have to rank it from high to low. Of course, you are aiming to choose those projects which yields the highest internal rate of return. So these 3 projects actually gives you the highest rate of return. 37%, 28%, and then 26%. So if I add all the cash inflows, so 5,000 plus 15,000 plus 12,000. So let me add it. So 5K, 15K, and then 12.5K. Okay, so this total is 32.5K, and she is within her budget. So she will choose C, F, and E. But let's say if she chooses project based on NPV, then of course you have to rank based on NPV. And you choose projects which yields the highest NPV. So then she will choose F, G, and B. And the internal rate of return for those projects, I'm not worried about. The only thing I'm worried about is NPV, because I'm choosing projects based on this criteria. Okay, let me go to the previous slide, something very important. So if I choose based on IRR, of course, every project has a certain NPV. So if I choose based on IRR, my total NPV, which actually adds to the shareholders' wealth, is $27,000. But if I choose based on NPV, it actually adds $28,500 to shareholders' wealth. This is the fun part now. If I choose based on profitability index, what do? I rank all projects based on profitability index. Okay. So then she will choose project F, B, C, and D. And if you see, the net present value is $38,000. Now, this is the fun part, as I said. If I choose projects based on profitability index, she will choose F, B, C, and D, and it will result $38,000 increase in shareholders' wealth. But if I choose based on NPV, it will add $28,500 to the shareholders' wealth. And then IRR is $27,000. So considering, let's say, if she is constrained to spend only $32,500, which means that there is a budget constraint, she is better off to use profitability index as a ranking method, because that one yields into highest value added or highest increase in shareholders' wealth. Okay, post-completion audit. So whenever a project is completed, what they do a post-completion audit. So it's a formal comparison of actual cost and benefits of project with original estimates. So let's say if you are undertaking a project, of course, the numbers on paper are estimates. That, okay, suppose this is a 10 years project, and at the end of the 10 years, let's say I will have this much net present value. But of course, once the project is completed, you are in a better position to compare your estimates against the actual cost and benefits. Why is it important? Because it helps you identify the project weaknesses. Sometimes there are problems in the project implementation. Sometimes there are problems in your estimates, your estimations actually. Okay, and the other reason we use post-completion audit, because it develops a possible set of corrective actions. Once you compare your actual outcomes with the estimates, of course, then you try to find out that, okay, where are the areas where we lacked in this project? Then you can take corrective actions. It's a feedback mechanism. So just like I always tell you that, okay, at the end of my lecture, please give me your feedback. Feedback, reason, with every lecture, of course, you have certain expectations. And then once you see the lecture, there may be a positive gap or a negative gap. If there is a negative gap, I use that feedback and then try to improve my future lectures. So post-completion audit is important because it helps you identify the weaknesses, and then you can take actually corrective measures, and then it's a feedback mechanism, which means it actually relates to this one, so that you can take corrective measures. Overall, the whole post-completion audits help you make better future decisions. Okay. There is another problem. It's called multiple IRR problem. So let's say we considered a very simple project. So let's say if I put it on the timeline for you, 0, 1, 2, 3, and 4. Let's say if you invest $100, and let's say if you get $25 in the first year, let's say $29 in third year, so second year, third year you get $40, and let's say $75 in fifth year. Of course, you can calculate one single IRR. One IRR. But let's say there is another project, and which is this one. What this project does, it makes an initial investment of $100. They get $100 back in the first year, $900 in the second year, and then the project involves an outflow of $1,000 in year number 4. And the reason is, some projects, for example, let's say if you are let's say if you are an exploration company which explores, let's say, oil exploration, right? Of course, you will make an initial investment. For example, there is a site where you would like to extract oil from. You make an initial investment. Can you hear me? Hello?
Yes, sir. आ रही है आपके पास.
Okay. Somebody tried to mute me. Okay, that's okay. So let's say if you have a project and if you are an exploration company, of course you have to make an initial investment. You move your machinery there, make an, let's say, construction on the site. But once the project is completed, of course you have to remove the machinery. And in some countries, you have to do some environmental work as well. Like, for example, tree plantation, or let's say something else. So there is always a cash outflow involved at the end of the project. These cash flow outflows can also occur in between the project life cycle. So whenever the cash flows changes a sign, so for example, sign here was negative, the first change was here. So this is one change in the sign. And then there is no change here. And then there is another change here. So whenever the cash flow changes the sign, you have that much of IRRs. So for example, in this particular case, we will have 2 IRRs. So all projects which has various cash inflows and outflows occurring at, let's say, different stages, it has a problem of multiple IRRs. Naturally, I would like to explain it to you through, let's say, an exercise. Let me see. Okay. Okay, let me share my Excel sheet. Can you see this, Azam?
Yes, sir.
Okay, so this is a very simple example. So for example, there is a very simple project in which we invest $100, just like this example that we considered on my PowerPoint slide. And there is a cash inflow of $100 and then a cash flow of $900. And then at the end of the project period, there is a cash outflow of $1,000. So for example, let's say I'm trying to find out an IRR. Hello. IRR is the rate at which your NPV is 0, right? So since the cash flows changed signs 2 times, so there are 2 IRRs, and I'll demonstrate it to you. So suppose I'm working with different rates. So let's say, let me Okay. Adam, can you hear me?
Yes, sir.
Okay, so my computer actually froze. Wow. Okay, let me. Okay, let me try it again. Okay, so let me share my screen again. Can you see my Excel sheet, Azam?
Yes, sir.
Okay, perfect. So time 0, 1, 2, 3, and cash flow was minus 100. And then it was $100, $900, and then minus $1,000. Okay. So let's say since I'm considering multiple IRRs, and I'll demonstrate it to you. So I'm starting with an interest rate of 1%, 2%, and then I'm going to, let's say, for example, let's say 230%. Okay. So the way I froze again. Okay, let me. Anyways, I'll send you actually the Excel sheet. My Excel actually is working very funny. It freezes all the time. Okay, I'll share actually my PowerPoint slides again. And I'll try to make it work actually. Anyways, so whenever these cash flows changes sign, so for example, it was initially minus, so the first change was here, and then of course plus, no change, and then the second change was here. So there are two potential IRRs here. So there is a problem of multiple IRRs. For example, for this example, the first IRR is here at 12.95%. So once you do actually, once you calculate NPV for, so what I'll do, let me give you an example. So for example, you have let's say time, and then you have cash flow, time 0, 1, 2, and 3, minus $100, then $100, and then $900, and then minus $1,000. Of course, and interest is, let's say, 1%, 2%, 3%, and then you go to, let's say, 200%. You can calculate NPV for each rate. So for example, NPV at 1%, NPV at 2%, NPV at 3%. And if you plot those numbers, the NPVs. There are two numbers at which the NPV is 0, and those numbers are by definition called the IRR. So IRR by definition is the rate of return at which your NPV is 0. So in this particular example, one IRR is 12.9% and the other one is 191.15%. So the internal rate of return, so for example, let's say if your required rate of return for this project, a required rate of return is equal to, let's say, 15%. So suppose you think that, okay, if the internal rate of return of the project is more than 15%, I will accept it. But if it is less than 15%, I will reject it. In this particular example, there are two IRRs. So what do you do? Based on this criteria, this cutoff, if you compare it with the first IRR, you actually reject the project. But if you compare it with the second IRR, which is extremely high, like close to 191%, of course you accept this project. So there is a problem of multiple IRRs. And multiple IRRs will occur if in the project life cycle, if there are positive cash flows and then negative cash flows, in other words, outflows and inflows occurring during the entire life of the project life cycle. Okay, I'm done with this chapter, and I'll unmute all of you now. If you have any questions, please ask me. The concepts are extremely, extremely simple. There is nothing technical about it. Let me show you, if I may. Let me try on the Excel, because are you still with me, Azam?
Yes, sir.
Perfect. So let's say time. Okay, let me share it before. If I write lots of stuff, and let's say if I cannot share it, then that's a problem. So time, cash flow, and let's say interest, and then NPV. Okay. So time is 0, 1, 2, 3. Okay. And the cash flows was minus 100, $100, $900, and minus $1,000. Okay, interest 1%. I'm trying actually to calculate NPV based on let's say lots of interest rate, different interest rates. So let me go to up to let's say 230%. Okay, so the way I calculate NPV, of course, you can calculate it by a simple command, equal sign, and then NPV. Double click on NPV. What it says rate. So I will choose rate here, comma, and then it says values. So I'll choose all these values. And since I'll be using the same values for all calculations, so I have to lock them. So I'll press F4 here and then F4 here. Okay, and then enter. Okay, so negative 88 for 1%. And when I double click it, so anything in red is actually negative. If you see here around 13%, this one is close to 0. NPV is close to 0. So around 13% we have one IRR. So IRR by definition is the rate of return at which your net present value is 0. Okay, what else I can do? I can select the whole series and then I can actually plot it. Ah, it froze again. This is very funny. Anyways, once you actually plot it, so go to insert, and then you can make a graph, line graph, and then you can visually see that actually there are 2 points which crosses that 0 NPV line, and those 2 points are the IRRs for that particular project. So we have a problem of multiple IRRs. And of course, if you compare one IRR with your required rate of return, you reject that project. But if you compare it with the other IRR, then you accept it. So it's something that you should be very careful of while evaluating a certain project. So in today's lecture, as you can see, we applied the IRR, net present value, and profitability index methods, because these are discounted cash flow methods. The payback period was not, so that's why we are not bothered about that. The most common used in real life are the discounted cash flow methods, which is IRR, NPV, and profitability index. We use them to different projects. In the first part of my lecture, we assume that, okay, there is no budget constraint. The company has unlimited budget, so you can take any project. In the second part of my lecture, what we did, we applied a budget constraint. So we thought that, okay, there are 8 different projects available for basket funders, but the maximum they can spend is $32,500. And then we applied different methods. Like, for example, we ranked the project based on IRR, and we picked certain projects. Then we picked projects based on NPV, and then we picked projects based on profitability index. And each method, of course, results in different decisions. Now, which method is more useful? Of course, the method which increases the wealth of your shareholders, in that case, the net present value. So profitability index in that particular example was the method which increased which maximized actually the shareholders' wealth. But let's say for a different budget constraint and for different project settings, for different available projects, maybe NPV is better. So it really depends on your budget constraint and the availability of the projects. So there is no rule of thumb, or let's say there is no no rule of thumb that, okay, this particular method is better than the other one. Of course, all of them come with certain limitation and certain advantages. In practice, they use all of them. They rank projects, and then they try to compare the NPV. And the process of comparing NPVs, of course, it's called the NPV profile. So every method has an NPV profile. And then you do sensitivity analysis that, okay, if my required rate of return increases beyond a certain point, what happens? And let's say if it less than a certain point, what happens? Any questions so far? Aksa, is that Aksa here?
Yes, sir, I'm here.
Okay, perfect. Aksa, what do you think? Was it easy or was it difficult?
Sir, the previous lectures were like more difficult. Like today's lecture was like comparatively easier.
Okay, so again, what I'll re-emphasize. Can you see my screen now?
No, sir, not really.
Okay, you can't. Okay, let me share again. Can you see it now?
Yes, sir.
Okay, perfect. So what I will recommend all of you, okay, all of you, to calculate these numbers, okay? So let's say, for example, on this slide, we have IRR of 28%, NPV of 21,000, and then profitability index of, let's say, let me actually, profitability index of 2.5. 40. So please calculate all those numbers. Once you calculate it, actually you will get a hold of, what should I say? You will actually develop the skills. How do we calculate IRR, NPV, and profitability index? Of course, there are tools which will help you, but at the end of the day, you should be able to do it manually. Okay. Do we have Asad today?
No, sir, he's not here.
He's not here. Faisal?
Absent.
Absent? Okay. And 126, Hamna?
Yes, sir.
Okay, Hamna, what do you think?
Yes, sir. Today's lecture was fine.
Okay,
I'll
perfect.
practice it and let you know.
Perfect, perfect. Okay, so I wouldn't take too much time. I will actually upload number 1 assignment and then the project. For project, it has to be a group project. Azam and Miraj requested for individual projects, but no, I think it's a little bit not practical for me as well to check like 29 projects. So it has to be a group of 6 students.
Okay, sir.
Okay. So Azam, do me a favor.
Yes, sir.
Do you want me to make the groups, or should I leave it voluntarily? I need the comments of all of you.
So you can make the group for us.
You can make the groups?
Yes, sir. No, sir, you make the group for us.
Okay, so then I'll make the groups.
Excuse me, sir.
Yes.
Sir, I think हम चूँकि अब सर मेरे 2 साल हो गए हैं and I know हम तकरीबन सबके साथ काम करके हमने देख लिया. So I think groups हम खुद बना लेंगे और वो ज़्यादा बेहतर होगा. Because we know
अगर आप लोग खुद बना लें तो अच्छा होगा.
Yes, sir, हम खुद groups बना लेंगे.
चलिए, हमारे पास 2 ओपिनियंस आ गए, ठीक है.
सर हम क्लास में ग्रुपिंग नहीं करना चाहते.
सॉरी, दोबारा से बताएं.
सर खुद ही बनाएंगे ग्रुप.
आप खुद ही बनाएंगे?
जी मास खुद ही बनाएंगे.
ठीक है. अच्छा, अगर आप खुद ही बनाएंगे तो फिर एक काम करें, ठीक है. Because the project actually carries 15% weight, तो मैं चाहूंगा कि आप लोग इस पे बहुत मेहनत करें, ठीक है, और give me a quality work, put your best foot forward, ठीक है, ताकि मतलब मुझे मतलब थोड़ा सा सेटिस्फेक्शन हो कि हाँ जो मैं पढ़ा रहा हूँ आप लोग इसको ग्रैब कर लें, ठीक है.
इंशाल्लाह.
तो ठीक है, 6 मैक्सिमम 6 स्टूडेंट्स, ठीक है, बल्कि 6 ही रखें, मैक्सिमम नहीं 6 ही रखें, ठीक है, क्योंकि मैं टारगेट रख रहा हूँ कि 5 प्रोजेक्ट्स मेरे पास आए और फिर उसको मैं इवैल्यूएट करूँ, ठीक है. तो एक ग्रुप 5 का होगा, ठीक है, और बाकी जो 4 ग्रुप्स हैं वो 6 के होंगे, ठीक है.
Okay, sir.
So please in the next 1 or 2 hours communicate with each other and send your groups to Azam, ठीक है, and then Azam can share with me.
Sir, I think you should make the groups.
Yes, sir.
Sorry, say it again.
Sir, I think you should make the
groups. सर आप खुद बनाए सर, रैंडमली वैसे ग्रुपिंग होती है सर.
सर जिसने बनाना है वो अपनी मर्जी से बना ले और जिन्होंने नहीं बनाना वो खुद बना लें.
ये बात है.
आप बनाए, it's better.
आपको बस जोक में
सर एक ऑनेस्ट ओपिनियन दे सकता हूँ सर.
आप हमें
बना दें ग्रुप.
जी सर, सिंपल सी बात है कि लास्ट टाइम भी ग्रुप्स बने थे, ठीक है, एक दफ़ा सर ने भी बना दिए थे एंड वी ऑल नो क्लास में सबको पता है कि क्या हुआ था, ठीक है. तो मैं नहीं चाहता कि दोबारा ऐसा कुछ हो, ठीक है. तो जो लोग कंफर्टेबल हैं वो आपस में ग्रुप बना के कर लें और जो कहते हैं कि उनके ग्रुप्स बना दिए जाएँ उनके ग्रुप्स आप बना दें सर. तो इट्स ईजियर फॉर एवरीवन और चूँकि सर बाकी जो कंफर्टेबल हैं वो इजीली कम्युनिकेट भी कर लेंगे और वो ज़्यादा ईजी होगा. क्योंकि कम्युनिकेशन गैप भी सर कुछ लोगों के साथ बहुत मुश्किल होता है कम्युनिकेट करना। तो और सर मेरे चूँकि मिड टर्म के अंदर मैं पर्सनली बताऊँ, मेरे मिड टर्म के अंदर मार्क्स इतने कोई इंप्रेसिव नहीं थे, इसलिए मेरा प्रोजेक्ट मेरे लिए पर्सनली प्रोजेक्ट बहुत इंपॉर्टेंट है। तो आई वुड से कि सर काइंडली हमें कंफर्टेबली ग्रुप बनाने दें अपना, और जिनको लगता है कि वो नहीं तो उनके ग्रुप आप बना दें। थैंक यू सर।
अच्छा उस्मान, मैंने आपकी ज्यादा बात सुन नहीं ली, लेकिन एक चीज मैंने सुन ली, ठीक है, उस पर मैं रिस्पॉन्ड करना चाह रहा हूँ। ठीक है, रियल लाइफ में, और मैं आपको मतलब जिस तरह मैंने आपको पहले भी बताया था, मेरी कोशिश होगी कि मैं आप लोगों को प्रैक्टिकल मतलब इंडस्ट्री के लिए तैयार करूँ। ठीक है, उसके लिए एक जो क्वालिटी आपको अपने में डेवलप करनी पड़ेगी। ठीक है, आपको बाज़ औक़ात अपने कंफर्ट जोन से निकलना पड़ता है। ठीक है, फॉर एग्जांपल लेट्स से अगर आप कहीं पे काम कर रहे हैं, ठीक है, तो यू डू नॉट पिक योर ओन टीम। ठीक है, आपको कहा जाता है कि भाई दिस इज योर टीम और ये काम आपने करना है। तो यस, आई अंडरस्टैंड योर पॉइंट कि आप अगर अपनी टीम में होंगे कंफर्टेबल होंगे, ठीक है, लेकिन फॉर ऑल प्रैक्टिकल रीजंस मतलब ये है कि आपको अपने कंफर्ट जोन से बाज़ औक़ात निकलना पड़ता है।
सर सॉरी इफ आई कट यू ऑफ सर, कंफर्ट जोन की बिल्कुल बात नहीं सर, वो आई टोटली अंडरस्टैंड कि सर जब भी आप वर्किंग एनवायरनमेंट में जाएंगे तो आपको सर कंफर्ट जोन से बाहर जाके मुख्तलिफ लोगों के साथ इंटरेक्ट करना पड़ता है, और वो बिल्कुल आपकी से बात ठीक है। बट सर यहाँ पे जो सिनेरियो है अबाउट कंफर्ट जोन, अबाउट कि अगर दो लोग, अगर आपको पता है ना आपकी कंपनी फॉर एग्जांपल चला रहे हैं, आपको पता है कि दो लोग काम नहीं साथ कर सकते ना, तो यू डोंट हैव टू गिव जस्ट फॉर द सेक ऑफ कि वो आपस में टीम वर्क बनाएं, आप उनको ना साथ। तो इट्स मोर इन द लाइंस ऑफ के who you get to work well with, और इस तरह से कहते हैं।
सर
ओके,
आप ही बना दें ग्रुप में यार, वो बेहतर रहेगा।
Also, okay, it's a time for decision making.
Sir,
yes.
No offense to anyone, but I think we've come across the times जहाँ पे we know each other and we can work with anyone we're assigned to. So we're classmates and I think we can work. किसी के साथ भी अगर ग्रुप बन जाता है, and I think 4 people would be better, or 5. 6 are too much क्योंकि फिर बहुत ज़्यादा rushing हो जाती है और फिर not everyone works. There's always one person that doesn't work. I think so.
I'm so sorry. My speakers are so bad. I'm sorry I couldn't hear you. लेकिन आप are you for the fact कि मतलब आप खुद ग्रुप बना लें या let me make it?
No, you should make it.
I should make those groups. Okay.
Yeah.
सर एक और बात है सर, काइंडली प्लीज 6 बहुत ज़्यादा हैं, तो आप काइंडली प्लीज़ कम कर दें। बेशक हम खुद बना लेंगे, ये भी एक अच्छा ऑप्शन है, आप भी बना लें, ऑप्शन अच्छा है, लेकिन 6 काफ़ी ज़्यादा हो जाते हैं। आई थिंक 4 से 5 ठीक है, क्योंकि हम इतना ज़्यादा मतलब नहीं करना चाह रहे कि बहुत कन्फ्यूजन बने।
अच्छा, फिर मैं काम
4 से 5 कर लें आप काइंडली। थैंक यू सर।
नो वरीज। तो हम इस तरह करते हैं कि फिर एक काम करते हैं, एक सेकेंड, हम इस तरह करते हैं, एक सेकेंड, हम इस तरह करते हैं कि हम ग्रुप ऑफ 3 10 प्रोजेक्ट्स भी मैं इवैल्यूएट कर लूंगा।
सर 4 कर दें सर।
3-4 is both good.
4 कर दें सर।
चलें
4
रखें, ठीक है,
4 कर दें सर।
तो 4 रख लें, ठीक है। और इसके बाद होगा ये कि एक ग्रुप होगा, फिर वो 5 का होगा, ठीक है।
सही है सर।
ठीक है, तो मैं ग्रुप बना लूं फिर?
यस सर।
सर जी सर, आपको सही लगता है सर।
सर आप बनाएं।
चले, ओके, सो द डिसीजन इज मेड, आई विल मेक द ग्रुप्स, ठीक है। आई विल शेयर जो ग्रुप की कंपोजिशन होगी वो आपके साथ शेयर कर लूंगा थ्रू CMS, और व्हाट्सएप के थ्रू भी कर लूंगा, ठीक है। प्रोजेक्ट में आपको दूंगा, मुश्किल नहीं होगा बिल्कुल, ठीक है, लेकिन एक चीज की गारंटी होगी कि अगर आप उसको डेडिकेशन के साथ करेंगे ना, लर्निंग आपकी बहुत होगी
इंशाल्लाह।
ठीक है, मेक सेंस?
इंशाल्लाह सर, इंशाल्लाह।
ओके, चलें, we'll stop here. I'll upload actually the
प्रोजेक्ट डिटेल्स कब शेयर होंगी?
Sorry sir, again?
सर प्रोजेक्ट डिटेल्स कब शेयर होंगी हमारे साथ?
मैं आपके साथ शेयर करूंगा by end of this week.
Okay sir. Okay, waiting.
ठीक है, okay, we will stop here and I'll see you inshallah in my next lecture.
Yes sir, inshallah sir.
Thank you very much for your attention. और जो मैंने कहा था कि स्लाइड्स के ऊपर जो कैलकुलेशंस हैं, प्लीज डू दैट, सुपर इंपॉर्टेंट। अगर आप नहीं कर पा रहे हैं, ठीक है, लेट मी नो। Okay, all the best. Allah Hafiz.
Allah Hafiz.
Over and out.